Welcome back to part 5 of the Kerberos deep dive series. I'm Alex, and in this part we continue our journey through the delegation features in Kerberos. Specifically, we are going to talk about constrained delegation. As in the other parts of this video series, also a quick note on Wireshark before we continue. Throughout this session, we'll be using Wireshark to inspect Kerberos traffic, and since Kerberos traffic is at least partially encrypted, that will make it much harder to analyze and look into the specific details. So in our lab setup and in the demos, you're going to see Wireshark has been provisioned with the key material, the Kerberos key material of all accounts in the infrastructure, so Wireshark will be able to decrypt the Kerberos traffic. So whenever you see a dissection of Kerberos in Wireshark and there is a blue background as demonstrated here, that means Wireshark has decrypted parts of the Kerberos traffic with the provided key material, and therefore we will be able to inspect it in clear text. If you want to learn more about this, more details are available in part 1 of this video series. So let's start with some basics on constrained delegation. As we've seen in the previous part of these videos, in Kerberos there are basically 3 main delegation mechanisms. We have the unconstrained delegation, which is covered in part 4, which basically just gives a system the right to impersonate users against any other service within your infrastructure. In this part, we're going to look at the constrained delegation, which adds some restrictions to how delegation can be performed. Specifically, it limits what other target services a system can perform the delegation against. And then lastly, we also have the resource-based constrained delegation, which reverses the way the delegation is defined, and this will be covered in part 6. So in this part, we're going to be looking at constrained delegation. Now for the basic mechanism, it's important to know that the constrained delegation was essentially introduced to address the issues that came up with unconstrained delegation, and it adds, as said before, some restrictions to the delegation mechanism. Specifically, the system that has delegation rights can only do so against certain other target services that are allowed. So if we look at that in an example scenario, we might have a user, we have some front-end services A and B, and we have some back-end services X, Y, and Z over here. Now with a user accessing service A and using constrained delegation, we might want to configure so that service A can only delegate against service X and Y, but not against service Z. And in another way, if the user connects to service B, the configuration might allow delegation to one backend service, but not the other. That is essentially what can be achieved with constrained delegation. Now, constrained delegation knows 2 basic modes of operation or flavors, and this all depends on what kind of authentication protocols are used throughout the whole mechanism. So the first mode is called a Kerberos only, which means from the user to all the way to the backend service, only exclusively Kerberos is used to authenticate and perform the delegation. So the user authenticates via Kerberos to the front-end service, and the front-end service which has the delegation rights then also uses Kerberos for the delegation mechanism to access the backend service as the user. This is the Kerberos only mode. In contrast to that, the other mode is called protocol transition, where the user might authenticate with any arbitrary protocol, and then there's on the delegation service a transition performed from that protocol to Kerberos. So for example, the user might authenticate using NTLM, and then the front-end service uses again Kerberos to reach out to the backend service and impersonate the user. This is the protocol transition mode. Now this part between the front end and the backend service, so the delegation itself, is always using Kerberos. If you want to configure constrained delegation, it's essentially the same as with unconstrained delegation. This is configured on the domain object, so either a user or machine account that should receive the delegation rights, and it again requires domain admin privileges, or specifically the SA enabled delegation privilege, which is by default only assigned to domain admins. If we have a look at how this might be presented, especially or in this case specifically in the Active Directory users and computers view, the setting is in the delegation tab of the respective account, and while the middle option was the one that we used previously for the unconstrained delegation, the lower option, trust is used for delegation to specified services only, corresponds to constrained delegation. And then you have to choose between one of the two modes we just covered. So either you select Kerberos only or use any authentication protocol, which is the protocol transition mode. And lastly, there's essentially the new feature that was introduced with constrained delegation, the restriction to which services the account can delegate to. So in our case here, we have just one target specified, the CIFS service on FS2 now. And then this list can, of course, be expanded to include all kinds of services that you would like the system to be able to delegate to. We can quickly have a look at how this looks like in our lab situation. So I'm on the domain controller. You can do the same from any system that has the Active Directory PowerShell module installed. And we can query the different account types with a specific filter to check which systems are configured for the constrained delegation. And we specifically request the properties, the one that controls where we can delegate to, and the mode of the delegation, the TrustedToAuthForDelegation. So in our case, we have one system or one computer account, WS1, which is allowed to delegate to the CIFS service on FS1, both with a fully qualified domain name and the net bias name. And we can see that TrustedToAuthForDelegation is set to false, which corresponds to the Kerberos only mode. If we go into the corresponding computer object, we can essentially see that this is the configuration that we see in the PowerShell output. Then we can also do the same for users. So just simply switch from AD computer to AD user, and we will see that in our case there's also a user account, the SQL service or SVC SQL, the actual account name is also configured for constrained delegation, but now the TrustedToAuthForDelegation is set to true, which means the protocol transition feature is active. Again, let's quickly check in the UI, the SQL service account, and in the delegation tab, we can then see that the use any authentication protocol is enabled for this specific service. So that's how you can query the configuration of your accounts in your domain. Okay, so first we start with the Kerberos only constrained delegation mode. To enable constrained delegation, Microsoft has added a new extension to their version of Kerberos called S4U2Proxy. And this mechanism replaces the TGT forwarding mechanism that we have learned about in unconstrained delegation. As a short recap, in unconstrained delegation, when you connect as a user to a system that is configured for unconstrained delegation, a copy of your TGT will be forwarded automatically to that system, and the system can then impersonate you towards any other services in the domain with your TGT. Now with S4U2Proxy, it works a bit differently. It allows a service to obtain a service ticket on behalf of the user that it wants to impersonate for another service. So the service that invokes S4U2Proxy then acts as a proxy, so to speak, on behalf of the user to access another service. And the ticket that is acquired by this means can then be used to actively access the target service. In a simple overview, it might look like this. So we have a user, we have a front-end service A and a back-end service B. And service A would like to delegate the user to service B. So what happens first is that since we are in Kerberos only mode, the user will authenticate using Kerberos to service A and presents their service ticket. And service A can then invoke the S4U2Proxy extension, which enables or which allows it to essentially trade in the service ticket of the user for a service ticket that is issued towards the target service. And with that service ticket, it will then be able to access the backend service in the name of the user. So for a service to use S4U2Proxy, certain conditions must be fulfilled. First of all, this only works, of course, if the service that invokes S4U2Proxy is configured accordingly for delegation. That means the trust is used for delegation to specified services only option is enabled, either with Kerberos only or with the protocol transition mode. That doesn't really matter in this case, but this, of course, must be enabled. And then the target service, essentially where the delegation service would like to have a ticket for, must be listed in this list of allowed targets for the delegation. And if both of those conditions are met, the service is allowed to invoke S4U2Proxy. Now there are some more implicit requirements for S4U2Proxy to actually work. If you think about the concept of delegation, so acting on behalf of a user, this should only happen if a user is actually present. So a system should not be able to just act on behalf of a user without the user in basically opting in to this mechanism. Now we've learned in the very beginning when we talked about unconstrained delegation that delegation is essentially transparent, so the user does not see it or have control over it, but still it makes sense that the delegation should only occur if a user is actually there. And this has been built into S4U2Proxy as well. So the S4U2Proxy extension should only work if a user has actively connected to the service that is configured for constrained delegation. And the way this works is that S4U2Proxy requires a proof of said user's presence. And this proof comes in form of the service ticket that the user presents to the front-end service in this case. So when the user connects to our service, which is configured for constrained delegation, the user will present the service ticket, and this service ticket serves as proof that a user is actually there and that the service A, the front-end service, is allowed to perform delegation on behalf of this user. Let's look at a bit more detailed view on how this actually plays out. So the starting situation is, again, as we've seen before, we have Alice. Alice has already gone through the process of acquiring a TGT, since this is not part of the delegation process itself. We then have the ticket granting server that it will issue service tickets. And then we have our front-end service here called web.local, also with its own TGT already, and the backend service db.local. And the front-end service in our case is now configured for constrained delegation with Kerberos only mode to the database. So that means whenever Alice will connect to the web server can then impersonate Alice against the database server. So what happens first in our process is that when the user wants to access web.local, Alice will request a service ticket for the respective service principal name. So that could be HTTP web.local. And when everything is in order, so the TGT is valid, the service ticket will be returned. With this service ticket, Alice is then able to connect to web.local and authenticate herself by the means of the service ticket. And now web.local will perform or trigger the S4U2Proxy mechanism. So it will go back to the ticket granting server and present two things. One, its own TGT to essentially authenticate itself, and then the service ticket of Alice that it has received in the previous request. Again, this is the proof that there's actually a user there that can be impersonated. Now the ticket granting server will validate everything. So it will validate the TGT, it will validate the delegation configuration. So is web.local actually allowed to delegate to db.local or not? And then it will also validate the service ticket, specifically the signatures within the pack. So not that the web.local has tampered somehow with the service ticket. Again, if every check is passed, the ticket granting server will issue the requested service ticket, now specifically for Alice. So this is a service ticket for Alice towards MS-SQL SVC on db.local. And with this service ticket, web.local can then connect to db.local and essentially act as Alice. So this is the whole process of how S4U to proxy plays out. Now we can look at an example set up in our lab environment. What we are going to see in the next demo is essentially the following setup. We have our user Trevor Massey. We have a front-end server, which is essentially a web server called WS1, and a backend server, in our case, a file share FS1. And on the file share, we have a piece of data, in our case a text file, that is only accessible for Trevor Massey. So the permissions, the NTFS permissions on this file are specifically configured to allow only Trevor Massey to access it. What we now can do with constrained delegation is that first we need to configure it. So we need to grant the front-end service delegation rights towards the file share. And that would, in this specific scenario, look like that. So we trust this computer, WS1, for delegation to specified services only. We set Kerberos only mode, and then we list CIFS on FS1 as an allowed target for the delegation. If we query that with the previously seen PowerShell command, the output would look similar to this. And now, whenever the user connects to our web application running on WS1, the web application can then invoke the S4U to proxy mechanism to receive a ticket in the name of Trevor Massey, and with this ticket then connect to the file share. And now when it accesses the file share, the permissions will be evaluated as if Trevor Massey himself would connect to the file share. So the rights assigned to the data that we want to access remain the same, and it is as if the user itself would access the file. Okay, so here we see a quick example on how this web application is made up. It's a very simple example. So we have some mechanisms in ASP.NET that will trigger the impersonation feature. They will establish a context in the impersonated user, and with that context, the application will then access our file. We can quickly check the permissions on this file. And we can see that only Trevor Massey is allowed to actually access the file. So if we try to access it from our web server, we can see that it fails. Now let's also run Wireshark on the web server to see what the actual traffic is that happens in the backend. We'll filter for web traffic from the client and Kerberos. Now on the client itself, we set up Wireshark as well, and then we connect to the application. And in the output, you can see that we have some basic information on which user authenticated, which user was impersonated, and then we can see that the file share access actually worked. Let's stop Wireshark and look at what happened on the client side. In our case, we'll add a additional filter to just display HTTP traffic now in our case, make it a bit more easier to read. Now we can see we start with a request to the web application, which is then answered with a 401 unauthorized, since we need to authorize ourselves, and we have the negotiate method available, which essentially will trigger Kerberos. We see then the client requests a ticket granting ticket for itself, so for Trevor Massey, and with the ticket granting ticket, it will then also request a service ticket for HTTP on WS1. And then with this service ticket, it will repeat the previous request to the application and present the authentication information. So the web application can then identify and authenticate the user that connects based on Kerberos in our case. So this is now the actual service ticket for Trevor Massey towards the web service. And then as a result, everything plays out on the web server and we get back the web page that we've seen before, so the actual data. Now let's switch to the web server and see what happens there. So we see again the same HTTP request as we've seen from the client. So the first connection, unauthorized answer, then the second connection with the service ticket. And now this service tickets that we have in here, HTTP WS1 for Trevor Massey, is the one that is going to be used in the subsequent S4U to proxy request. This will be this next step here. So it's a TGS request since we request the service ticket. And if we drill a bit down into this, we will first see that in the pre-authentication data, we have the actual TGT of our web service. So the web service operated by WS1. So we should see here a TGT issued to WS1. So this is the authentication material it's sent in our TGS request. Then next to the actual authentication data, we have some other information in the request body that now instructs the KDC what we actually want to do. And what we want to do is receive a service ticket for CIFS on FS1, so the target where we want to delegate to, in the name of Trevor Massey. So the name, or in the name, this information of who we want to impersonate, this is provided in this additional ticket data structure. And the additional ticket data structure contains the copy of the user's service ticket. So if we go have a look in that, first we can note that the cipher begins with FDDCF. And if we look at the user's service ticket that was sent along, we should see the same information since it's just forwarding this ticket. So you can see here FDDCF. So this is really the same ticket. And then our delegation service will simply send along this the copy of the user service ticket. And if everything is validated correctly on the KDC, so if delegation rights are properly configured for what we want to request, in the reply, we actually get now a service ticket for CIFS on FS1 in the name of Trevor Massey. So this is the result of the S4U to proxy request. And if we look at the cipher here, the ticket is 238AA. And then in the subsequent SMB request, where Kerberos is now used to authenticate and access the file share, we should see the exact same cipher since this is the ticket used to access the share. So again, we have the ticket for CIFS on FS1 with the cipher 238AAD. And this then completes essentially the whole delegation or mechanism or S4U to proxy step. Now that we have seen a working example of Kerberos constrained delegation, we also need to talk about how the service ticket validation during the S4U to proxy request actually works and what factors are considered. We already know that S4U to proxy requires proof that a user is present, and this proof comes in the form of the user's ticket. However, there are certain requirements that apply to this scenario, so not all tickets, all service tickets of a user might actually be eligible for the S4U to proxy exchange. Specifically, what must be the case is that the ticket that is presented as the user's presence must be flagged as forwardable. Now, the forwardable flag is by default always set on a user's ticket. So whenever you as a user request a service ticket towards a service, the ticket is normally flagged as forwardable. However, there are certain conditions that remove this flag. First, there is the protected users group. So we have already heard about this in the unconstrained delegation part of this series. Now, the protected users group is a built-in feature in Windows Active Directory that can be used to add additional protection measures to a certain group of users. And among these protection mechanisms applied to the users, one thing is that Kerberos delegation is disabled. And the way it is disabled is simply that the forwardable flag is removed from this user service ticket. The same thing happens as well if the user is marked as sensitive. So for a user marked as sensitive, the forwardable flag will also be removed. And then lastly, there's another mechanism to acquire a service ticket in the name of a user, which is called S4U2Self. This is part of the protocol transition feature of constrained delegation, and we'll talk about that in the next section. So for now, you just need to remember that when the user is protected, a member of the protected users group, when the user is flagged as sensitive, or when S4U2Self is used without the proper configuration, the resulting service ticket will not be flagged as forwardable and therefore will be ineligible for the S4U2Proxy mechanism. To demonstrate this behavior, we go back to our lab environment where we have the demo that we used before. We can see that in the case that we currently have, everything is working as expected. The ticket that we as a user use to access the web service is flagged as forwardable, so it can be used in the S4U2Proxy scenario. Now, if we configure our user to be marked as sensitive, we can see how this influences the whole process. So we have changed this. We go back to our client. And now first we have of course, to clear our ticket cache so we don't use the existing ticket. And now if we refresh the page, simply we see that now we get an error. From a user perspective, it's not so clear what happened now. The authentication still worked, so we are still authenticated with Kerberos, but for some reason the delegation no longer works. If we look at our ticket, we see a first hint as to why that might be. So the service ticket is no longer flagged as forwardable. And we can also see that in the Wireshark trace when we request the actual service ticket. So for HTTP on WS1, the resulting ticket that we get back has the forwardable flag missing now, since our user is marked as sensitive. And this is then the reason why we can no longer perform the delegation. Now, the access to the web app still works fine. If we switch to the server side, we can we have Wireshark in monitoring mode as well, so we can see that we have again the initial request with the unauthorized status, and then in the follow-up request, our client sends the Kerberos ticket. So this part of the authentication still works as expected. There's no problem with that. But as in the ticket, the forwardable flag is missing, we then eventually get the error that the web server was not able to access the file share since there was no authentication material present. Now, the interesting thing is that here we don't see any Kerberos S4U2Proxy attempts, and this is simply because the web server will not attempt to do S4U2Proxy with a ticket that is not forwardable. What we can do is we can add SMB to the protocol filter, and we see that the web server tries to reach out to the file share, but since it has no authentication material available, the request will then eventually simply fail, and that's why we get the behavior that we see in this example. To actually demonstrate the behavior or the difference in behavior when using forwardable and non-forwardable tickets, we can go back to our demo setup again. You see currently everything is working as expected, so the delegation was successful. And if we look at the tickets that we currently have in the cache for our user, we can see that the ticket for HTTP on WS1 is indeed forwardable, so it is usable in S4U2Proxy. And now to actually then use that ticket to demonstrate, we'll first have to dump it. We're going to use Mimikatz for that with the secure LSA ticket command. So this will flush out all the tickets in the cache and write them to disk. And now before we continue with that, we will switch our user to being marked as sensitive. So the resulting ticket will no longer be forwardable. Let's go back to our client. We purge our ticket cache and then simply refresh the demo application. And now we can see as before, the delegation no longer works. The ticket that we now have in cache is indeed no longer marked as forwardable as expected. So now we can see the difference side by side between those two tickets. So the one that we had before and the one that we have now. Now we can flush this ticket out as well by simply repeating the Mimikatz command, and we should now have both tickets on disk. We can see that we indeed have two tickets for Trevor Massey on HTTP WS1. The question is now which one of these is which, and the nice thing is that Mimikatz will actually include the flags of the ticket in the ticket name, so we can see a difference there by just looking at the names. Now the question is which one is which, and we can figure that out by simply mapping it to the output of the klist command, for example. So let's move that side by side so we can have a direct comparison. And if we check the forwardable ticket, we see the flag is 40A1, and we have that here as well, 40A1. So the lower ticket is the forwardable, and for the non-forwardable ticket, the flags is simply A1000. So we have that in the upper one. So the lower one is the forwardable, and the upper ticket is the non-forwardable. With those two tickets, we now move them over to our Rubeus directory, so we have them cleaned up a bit, and now we can actually use Rubeus to perform SVU2Proxy. First, we're going to reset Wireshark so we have a clean trace, and then we can start experimenting. So the first thing that we are going to do is use the forwardable ticket. With Rubeus, we can use the S4U command, and for this then we have to specify the user that wants to perform the delegation. So this is actually the machine account that is configured for delegation, so WS1, and along with that we also need to provide the credentials, so the key material. Now this we can, for example, retrieve from the key tab file that we generated earlier, or you might dump them from the LSAS or from other means. Doesn't really matter for this purpose right now. So we just simply copy the RC4 hash, and then we specify the service where we want to delegate to. Now this has to be in line with the configuration of the delegation. If we check what is currently set on our computer object, we can see that CIFS on FS1 is a valid target. So we specify that in our case, and then we have to provide the ticket that is proof. So either that can be base64 or it can be an actual file. So let's first take the forwardable ticket and provide that. And let's see what happens now. We reset Wireshark again and send the request. And now we can see that this seems to have worked. So in the first step, Rubeus will request a ticket granting ticket for our account, so WS1, so this is as expected, and then SVU2Proxy will be triggered, which is in our case successful. So in Wireshark we can see as well in the request, in this SVU2Proxy request that we send, the ticket that is included in the additional ticket data structure is indeed forwardable and therefore eligible for SVU2Proxy, and as a result we get the service ticket for CIFS on FS1 in the name of Trevor Massey. If we do the exact same thing but use the non-forwardable ticket, we should now clearly see the difference in behavior. Again, the first step will be requesting the TGT. Nothing has changed there, so this is still valid. But now, SVU2Proxy seems to fail. And the KDC simply returns this bad option error. If we check in Wireshark, it's apparent why this is the case. In the additional tickets data structure, we now have, as we know, the ticket not marked as forwardable anymore, and therefore the KDC simply returns the according error. If we as an attacker want to abuse Kerberos only constrained delegation, there are certain things to keep in mind. What we already have learned is that in Kerberos only mode, the authentication from the users or the incoming authentication to the delegation server must occur over Kerberos. So this essentially equates to a user's presence being required for the delegation to be performed. And that means we as an attacker need essentially two things. First, we need to have control over the account that is enabled for constrained delegation. So that could be that we have local admin permissions on the system, or we have the credentials available for the account. Secondly, to fulfill this user presence requirement, a user must actively connect to our target account, so the account that is enabled for delegation. Now, there are certain ways around that. I'll briefly touch on them in a few moments, but generally these are the requirements to abuse the Kerberos only constrained delegation. As a result, if everything is fulfilled, as an attacker, you'll be able to impersonate the users that connect to you against all the allowed targets within your configuration, within the delegation boundaries that have been set for your given account. Now, to bypass this or to work around this requirement of a user having actively connect to your system, there are certain techniques that can be used for this. Essentially, what you have to do is you have to be able to acquire a ticket that can be used in the S4U to proxy mechanism without a user actively connecting to your system. Especially what you can do is combining resource-based constrained delegation with constrained delegation in the Kerberos only mode. This will be covered in the last part of our video series in more details. If you want to know more about this as well, I can recommend the talk of Charlie Bromberg from Insomniac 2022. Before we jump into the demo, let's quickly summarize the attack flow that we are going to see. So we have, to begin with, certain specific scenario setup. We have, for one, of course, we have the KDC, so our domain controller. We have a file share that can be accessed via delegation. We have the front-end service WS1 that is configured for constrained delegation towards the file share. And then we have a user, an admin, and our attacker. Now, what must happen first is, of course, the attacker must have control over the system that is configured for constrained delegation. So essentially, we need to get local admin rights somehow on this box. Next, as the user needs to be present for the delegation to occur, we must somehow either convince the user to connect to our service, WS1, or we simply wait for this to happen. So this is not strictly required, but we might help our luck a bit with certain coercion techniques. Now, we're not going to look into much more details about that, because essentially this is another topic. But eventually what must happen is that the user that we want to impersonate must connect to our target service. If the user does so using Kerberos, the user will authenticate using his or her service ticket, and the service ticket then essentially is cached on the target system for the duration of the impersonation or the delegation. As we have local admin access to this machine, we will be able to extract this service ticket. There are various tools for that. And once we have this service ticket, this is essentially what we need to as proof for S4U to proxy. We as an attacker can then trigger the S4U to proxy flow against the KDC. And since we already have control over this machine that is configured for constrained delegation, we can also steal its key material or the TGT stored on the machine, so we can use that as well for S4U to proxy. And then if everything is in order, so if we request a delegation for a system that is a valid target, we will get back the service ticket in the name of the user, and will subsequently be able to access the resource as whoever connected to our system. So in this case, that will be an admin user. Now that we have seen the attack flow, let's actually play this through in our lab environment. First, we are quickly going to verify the current delegation configuration. So we have WS1 being allowed to delegate to CIFs on FS1. So that means whoever has control over this account will be able to abuse the delegation. To simulate an attacker having control over WS1, I'm running a system shell on this host, and with this system shell, we will be able to fully interact with all key material or credential material and Kerberos tickets. First, let's quickly look what we already have in cache. With the Rubeus klist command, we can see that there are some tickets for the machine account itself, so WS1, some other tickets for the service account, and so on and so forth, but currently nothing of too much value to us. Since we're running Kerberos constrained delegation in Kerberos only mode, we need somebody to actually connect to us so we can abuse their ticket. And this we are going to simulate by connecting from the domain controller in the name of a domain admin back to WS1. I'm using PSExec for this. This will trigger an SMB connection with the Kerberos as authentication layer. So we'll let the command complete. And if we switch back to WS1, we'll see in the Wireshark trace that we indeed got an SMB connection incoming, which has Kerberos as the authentication layer. And if we dig down into the actual Kerberos data structure, so in the AP rec part of this message, we can see that the ticket that is included here eventually will be the ticket for the lab admin towards this system, and it is marked as forwardable. So that means we can abuse it as in the S4U2Proxy command. So we can quickly list the tickets again with Rubeus klist command, and we now can see that we indeed have this ticket of lab admin available in our cache. Now, the next step for us as an attacker will be to somehow make this ticket accessible. For example, we can use Mimikatz to dump the ticket. This is simply the command secure LSA tickets with the export flag, and that should flush out all the tickets that are currently in cache to disk. Now, these might be a lot of tickets, but we just need to pick out the right one then. So let's look at the results. We should have all the tickets on disks. You can see quite a lot of them, but we're simply interested in the ticket of the lab admin for CIFS on WS1, and this is quite easy to spot down here. So this is the ticket that we will actually be using for our attack in the S4U2Proxy request. So this, you can see that is the current ticket that we just dumped. Now, with this ticket, we can then as I said, abuse the S4U2Proxy step or mechanism, and this can be done with multiple tools. We're going to be using Rubeus for that. And now for the S4U command, we need to provide some form of authentication that identifies our current account, so the WS1. Either we specify user and the password hash or the Kerberos key material, or we provide a TGT. In our case, the easiest thing to do, since we're already running on the machine, we can just request a TGT with the TGT deleg command of Rubeus. We've talked about that in the unconstrained delegation section in more detail. So if we execute this command, we get a usable TGT that we can then pass on to the next command. Now with this TGT, we can now start the actual abuse of the S4U2Proxy step. So let's repeat that again. We specify the S4U command, we provide the TGT that we just requested, and then as a next option, we need to pass in the service ticket of the target user that we want to impersonate. So that is the ticket of the lab admin that we previously dumped to our disk with Mimikatz. And Rubeus simply allows us to copy the path to this file and provide it on the command line as argument. And then we also need to specify the target service where we want to perform the delegation to. Now this has to be in line with what is actually allowed for our account. We can quickly verify that if we check again the current configuration, and we can see that we can delegate against CIFS on FS1. So we need to provide that as well, of course, in the right format. And this should then complete all the requirements for the command. Let's see if it works. So it seems to be successful. We got a actual ticket, so we can see that Rubeus will load the ticket that we provided from disk, and from that we'll build the S4U2Proxy request to request a service ticket in the name of lab admin to CIFS on FS1. So in our case, this seems to be successful because we have fulfilled all the requirements. The ticket is forwardable, and we specified the correct target service. And now to actually use that ticket, we can either dump it again and use it further, or we can pass along the PTT flag. So we just repeat the command and say we want to pass the ticket into our current logon session. which has worked as well. And now if we use the klist command, we can see that we have the resulting ticket for CIFS FS1 in the name of labadmin in our current logon session. And that means we should now be able to access the file share, for example, the C dollar drive on FS1. You can see that works perfectly. And this requires admin privileges. So that indeed is an indication that we now have successfully abused the permissions of the domain admin. Now, with the Kerberos only mode fully covered, we can also look at the second mode of operation, the protocol transition. First, we start with a quick scenario why this was even introduced, or what might make it necessary to have this mode besides the Kerberos only option. Consider that we may have a roaming client that is outside of our internal company network. So we have some target services within the network, and the client itself is on the outside, firewalled, and the Kerberos authentication directly through the firewall is not allowed, it's blocked. However, what is possible is HTTPS, so the client might use HTTPS to authenticate towards the web server, and the web server now has delegation rights, so it would like then to perform delegation, Kerberos delegation, towards the database in the backend. Now, there are some issues here at play. The initial authentication that the user performs towards the delegation system is using, in our case, HTTPS and not Kerberos. Could also be some other mechanism, NTLM or whatever you can think of, but essentially it is not Kerberos. Therefore, when the target system wants to transition from whatever is here to Kerberos, there is a big problem, because as we've seen before, the S4U2 proxy mechanism requires the proof of the user's presence, and this comes in the form of a service ticket. However, as the user has not used Kerberos to authenticate, there will be no service ticket available. So the invocation of S4U2 proxy will not work in this case. So to address this problem we just discussed, the second mode, the protocol transition mode, was added to constrained delegation. So in Kerberos only mode, we already know that the initial user authentication must occur over Kerberos. There's no other way around that. However, in protocol transition, the user can authenticate via any means to the delegation service, and then the delegation service will translate the authentication to Kerberos. So the initial authentication of the user can take any form that you can think of. It could be NTLM, it could be a username and password submitted on a website. It could be a federated authentication by an IDP, and any other means that could possibly be implemented. To enable the protocol transition feature in constrained delegation, Microsoft has added an additional extension to the Kerberos protocol called S4U2Self. With this protocol extension, a service is able to fetch a service ticket on behalf of a user. So the user we want to impersonate our delegation, and this service ticket is meant for the service itself. So the service ticket that then is created via S4U2Self is essentially the proof of the user's presence again. So we end up at the same point as before with S4U2 proxy, where we need a proof of the user's presence. And as a next logical step, and this is indeed what happens as well with protocol transition, the service can then invoke S4U2 proxy to exchange this proof that was just created for an actual service ticket for the target service. So schematically, this works as follows. We have a user that connects to a front-end service that is configured for constrained delegation with protocol transition, and then we have a back-end service where we want to perform the delegation towards. So when the user authenticates to the target service in the front end, the user can use any form of authentication, as we've learned before. That could be NTLM, for example, and the receiving service will then translate this incoming authentication towards Kerberos. So the first step that the service will perform is to invoke the S4U2Self extension or request. And within this request, it will basically exchange or prove that it is who it says it is with its TGT. So it will authenticate itself towards the KDC and then get from that a service ticket. Now the service ticket is intended, as we've learned before, for itself. So with that service ticket, it will not be possible to connect to another system, but this service ticket satisfies the requirements for S4U2Proxy. Since for S4U2Proxy, we need a ticket that was issued to our current service as the user. So with this service ticket, the service can then invoke S4U2Proxy, where it exchanges that service ticket for itself for another service ticket for the intended target service. And then, as before with constrained delegation with Kerberos only, this resulting service ticket can then be used to actually access the backend service. Now, if you have paid close attention to how this mechanism actually works, you might have noticed something a little bit strange. What I'm hinting at is that there is no actual connection between the incoming user authentication and the S4U2Self request. So while most services will only trigger the S4U2Self request once a user has authenticated, there is no technical connection between an incoming connection of a user and the S4U2Self request. That means that the S4U2Self can be used by the service that is configured accordingly to create a user presence proof, so the service ticket, by itself. The interaction with the user or the incoming authentication of the user is not actually required for this. It's just intended that way, but there's no technical enforcement of a user connection or user authentication happening before S4U2Self can be invoked. This means that the delegation service, so the service A that is configured for constrained delegation with protocol transition, can simply decide to impersonate any user it wants out of thin air. So even though most scenarios will involve a user connecting before S4U2Self is triggered, the service could at any point in time decide to invoke S4U2Self for any user, since it doesn't have to provide any proof of the user authentication that has happened before S4U2Self is invoked. This specific permission that a service with the protocol transition mode has is called TrustedToAuthForDelegation. So this is the additional privilege assigned to an account when it is enabled for protocol transition. This is part of the user account control, so it is a flag within this data structure, TrustedToAuthForDelegation, and every account that has this flag set can essentially perform the impersonation of any arbitrary user in a Kerberos delegation context. So that's what you also can query for. We've seen that in the first example. The TrustedToAuthForDelegation flag will then return whether or not, or property will then tell you whether or not this right is granted to the respective account. Let's now visualize the actual protocol flow when we use constrained delegation with protocol transition. So for the starting situation, we have again our ticket granting server. We have a system that is configured for constrained delegation with protocol transition, web.local, and in the backend we have db.local, so basically the recipient for the delegation. And technically, in most cases, or in like a regular use case, you would have a user connecting to the delegation service. But as we've learned before, this is not strictly required, but it is included for completeness sake here. So the first thing that would normally happen is that a user authenticates towards the delegation service. Again, optional in our case, but it completes the picture. And then the delegation service will first trigger the S4U2Self request step. So it will go back to the ticket granting server, present its own TGT, and with that request a service ticket in the name of the user that it wants to impersonate. So for example, Alice. And the ticket will be requested for itself. Now, itself is always the account that is operating the service that was initially contacted. So if the SPN registered here is mapped to the account, to the computer account, it will be $. If it is mapped to a service account, it will be for that specific service account. Once the TGS receives the S4U2Self request, it will verify whether the requesting account, so $, in our case, is actually allowed to perform the protocol transition. So it will just look up the configuration, and if that lines up, it will return the requested service ticket. So this service ticket that results from S4U2Self is intended for web.local, and it represents Alice as a user. With that completed, the next step is then S4U2Proxy, since web.local now has proof of a user being present, essentially, even though that is not technically the case, and it can trigger S4U2Proxy. In S4U2Proxy, it will send its TGT, again, to authenticate itself, and the user presence, so the service ticket that was just previously acquired. And then with that, it will request a service ticket in the name of Alice for the target SPN where it would like to perform the delegation. So in our case, that will be MS-SQL SVC on db.local. Again, the KDC will check if everything is in order, specifically if the delegation permissions allow this form of delegation. So this SPN here must be in the target list of allowed delegation targets on web.local. And again, if this is okay, the KDC will return the new service ticket for Alice, which is now intended for the backend system db.local. And with that, the delegation system web.local will then be able to connect to db.local in the name of Alice. Before we look at the actual example of Kerberos constrained delegation with protocol transition in our lab, let's quickly discuss the setup that we are going to see in a minute. So we have, again, a user, Trevor Massey, we have a front-end system, WS1, and we have a back-end system, FS1 in our case, that has a file which is only accessible to Trevor Massey, and then we have the constrained delegation with protocol transition in place, specifically for WS1, which is enabled to delegate towards FS1. So we can see for WS1, we have set the trust is computed for delegation to specified services only property with CIFS on FS1 as an allowed target. Now, when Trevor Massey then authenticates towards WS1. Now the means that he uses to authenticate can be any form. It could be NTLM, it could be a username and password in a web form and so on. That doesn't really matter. But WS1 will then be able to invoke S4U2Self and S4U2Proxy and therefore impersonate Trevor Massey against FS1 and with that access the file share with Trevor Massey's permissions. Now in our lab setup, we have more or less the same setup as before. We have again our small web application that will perform a user impersonation and try to access a file share in the name of the impersonated user. So this is the same setup as before. The only thing that has changed is that we now have switched the mode of Kerberos constrained delegation. In addition, to enforce the point on our web server, we only have NTLM now enabled as an authentication method. So the client will not be able to authenticate using Kerberos, and we can see how this then plays out. Otherwise, the application is still the same as before, so it will display the name of the user that has authenticated and that we impersonate. We also have Wireshark running in the background to record everything that is happening on the web server side, and the same on the client as well. Now on the client, we first will purge our current tickets, so we start from scratch and then navigate to the actual web application as before. Now, we will see in the Wireshark recording that the form of authentication that takes place now is not Kerberos but NTLM. It will happen automatically through single sign-on in Windows, and we can see that the result is exactly the same. So the user is still authenticated as Trevor Massey, the impersonation seems to work, and the web server is able to access the file share in our name and fetch the data. In the Wireshark recording, we can now see that there's no more Kerberos involved, but rather NTLM. So once we get the unauthorized message back from the server only offers NTLM as method to authenticate. And based on that, our client will then trigger the NTLM handshake. So it will get a challenge, it will send a response back, and so on and so forth. And in the last or in the final message, the client will then present its NTLM authentication material to the web server to authenticate. As a result of that, the client then knows the server knows the identity and will deliver the actual content of the application that we've seen in the browser before. Now, when we switch to the web server, we can see what happened in the backend. Again, we have essentially the same picture, or at the beginning at least is the same picture as we've seen on the client. We have a request that is answered by an unauthorized message, followed by the NTLM negotiation, the NTLM handshake. And once this has been completed, the server then knows our identity. Trevor Massey can start the impersonation or delegation process. So the first thing that it will do is then call S4U to self. So these are the first two requests that we can see in the Kerberos part, and then it will perform S4U to proxy. If we look a bit more closely into the S4U to self request, we can see that in the PA data structure, so the pre-authentication data structure, we send along our TGT, so the TGT for our service account. This is WS1. This simply serves to authenticate these requests towards the KDC. So this has nothing to do with S4U to self. This is regular Kerberos behavior. So we can see here the ticket is issued to WS1. Then what we actually ask in the S4U request is a ticket issued to ourselves. So in the service name property, we'll see our own account listed, WS1. And what's missing now is who this ticket should be for, and this is contained in the PA for user data structure. So if we open that up, we find eventually Trevor Massey. So we ask for a ticket for Trevor Massey to ourselves. The purpose of S4U to self. The KDC will then busy evaluate everything if we were allowed to do that, if Trevor Massey can be impersonated, and so on and so forth. And if everything looks good, it will return the requested ticket. So the ticket will be in the name of Trevor Massey as requested, and it will be issued towards our own account, so WS1. Furthermore, we can also look at the flags. The ticket will be forwardable. That means it's usable in the S4U to proxy request. And just to make sure that this actually works, we can then look at the next step of the request, what happens after that. So once S4U to self is completed, the server will move on to S4U to proxy. Now in S4U to proxy, we already know what happens here. We send a request body, again, our TGT in the PA data, nothing new. And in the request body, we request a ticket for the actual delegation target, so CIFS on FS1. And as a proof that we are allowed to do that, we send along an additional ticket. Now this is the ticket that we just fetched with S4U to self. So if we look at the properties, this is the ticket that we've seen before. We can also quickly verify this via the cipher. If we take note of this, it's 879AD. And if we go back to the response of the S4U to self request, we can see that the ticket we get back has the same cipher, 879AD. So this is just a copy of this ticket that we got there. And since it is forwardable, it will be valid for the S4U to proxy request. And as a result of this, the KDC will issue the ticket that we actually want, so sifs on FS1 in the name of Trevor Massey. And with that ticket, the web server will then be able to reach out to the actual file server. It will send along this specific ticket, and with that ticket, it will be able to impersonate the user, Trevor Massey in our case, towards the file share. A few more details on how S4U2Self and S4U2Proxy play together. Performing S4U2Self does not actually require any specific permissions. So any service or any account within your domain can invoke S4U2Self. The only thing that you need for it to be successful is you have to have a service principal name configured. Since you request a ticket for itself, this operation only can work when you have a service principal name. But apart from that, S4U2Self can be invoked by any account in your domain. However, the resulting ticket that you get from that, so the ticket in the name of a user to yourself, will not be forwardable in certain conditions. First of all, if your account is not configured for constrained delegation with protocol transition, you can invoke S4U2Self, but the ticket is then not forwardable and therefore not usable in S4U2Proxy. If the account you ask the ticket for, that you want to impersonate, is flagged as sensitive, as we've seen before, or if the account is member of the protected users group. So in any of those cases, the resulting ticket from S4U2Self will not be forwardable. And as we've learned in the previous section, non-forwardable tickets can then also not be used in the S4U2Proxy step. Now, even if those conditions that we've just talked about prevent most of the services from getting a usable, meaning forwardable ticket via S4U2Self, there might still be a use for any given service to call S4U2Self, specifically to facilitate local authorization decisions. What I mean by that is that the service ticket that you request or get back from S4U2Self contains the target's user authorization data. So if a service requests a ticket, let's say for the user labadmin with S4U2Self, this ticket, no matter whether it's forwardable or not, will contain the user authorization data for labadmin within the privileged attribute certificate or PAC. So that means a service can request for any given user a ticket with S4U2Self, then extract the authorization data from it and use that data to make authorization decisions. So it will be essentially the same as if the user already authenticated initially via Kerberos, and you have the same data available. We can quickly look at that in the lab environment as well. We go back to a previous recording where we have the S4U2Self and S4U2Proxy requests. Now the first two that we see here are the S4U2Self exchange. So if we look again at what was requested, we see that we request a ticket to WS1, so to ourself, and we request that for a specific user, specifically for Trevor Massey in this case. As a result, we then get back this ticket, and in the ticket itself, within the encrypted part, we will eventually find the authorization data structure. Now the flags are not relevant for this, so whether the ticket is forwardable or not doesn't matter. But within the authorization data, we will find the logon information, and in here you can see all the data like password last changed, user IDs, group IDs, and so on, that you can then take and consider for authorization decisions on your system. Now to switch to the attacker's perspective, how and under what conditions can you attack constrained delegation with protocol transition? We've already learned that if protocol transition is enabled, we don't need any specific form of authentication from the user towards the delegation service. So the delegation service can simply impersonate the user without any user interaction being required. So the conditions that we need to be fulfilled as an attacker is essentially that we need to have control over the account that is configured for constrained delegation. So We need to have access to the account's password, key material, TGT, or so on. And we basically just need to know the principal name, so the identifier of the user that we want to impersonate within the domain. But no other requirements as a user that would connect to our service. And with that, we can then simply impersonate any user that we want against the allowed targets. So the situation, the attack flow that we are going to see next in demo essentially looks like that. The user is basically out of the picture because we don't really need a user to be present. Normally for the protocol flow it will be the case, but for the attack it's not required. So we again have the same setup as before. We have the domain controller, we have the target of the delegation, this is the file share on FS1, and we have the delegation system, WS1, which is configured for constrained delegation with protocol transition to FS1. What we first need to do as an attacker is to compromise and gain local admin rights over, in our case, this system here. So again, this is just so we are able to extract key material, TGT, and so on from this respective service. With that, then this is exactly the next step. We will dump the TGT or the key material of the account that is operating the service, so the specific account that is enabled for constrained delegation with protocol transition. And with this TGT, we are then able to trigger first the S4U to self flow and then S4U to proxy. So for S4U to self, we simply present the TGT and ask the KDC to return a service ticket for any given user that we want. That could be an admin to ourselves. If everything is in order, this service ticket is returned, and now this service ticket, as I mentioned before, can be used as proof in S4U to proxy. So the next step will be we invoke S4U to proxy, send along the service ticket that we just got back, and as a result, we will get a service ticket for the actual target system that we want to connect to. Now, of course, here again, the same constraints apply as before. We actually must follow the configurations that have been given for the delegation. So if WS1 would not be allowed to delegate to FS1, this of course would not be possible. So we must ask for a service ticket for a target system that is allowed for delegation. But if everything is fulfilled, the service ticket will be valid for the delegation, and we can then access the backend service or the target service as any user that we want to impersonate. And now then this step above here can then simply be repeated as many times as we want for any given user that we want to impersonate. Now we will look at two different instances on how this can actually be abused in our lab environment. The first example that we're going to see is when the constrained delegation with protocol transition is configured on a machine account. So we are back in our lab environment, and first we quickly check how the delegation rights are configured. So we currently have a computer, WS1, so the machine account of this computer is allowed to perform delegation towards the file share on FS1, and we can also see that the protocol transition is enabled. So TrustedToAuthForDelegation is set to true. Now, to abuse this, we again simulate an attacker having full control over the target machine. So we are running a system shell on WS1, and within this system shell, we can then essentially operate with the key material and the tickets of our machine. So the first thing we are going to do is request a ticket granting ticket using the TGT deleg mechanism. We've seen that in the unconstrained delegation part of our video series. And then we use this TGT to request a or trigger the S4U flow. Now S4U now will do both steps, S4U to self and S4U to proxy. And the first thing that we specify is which user we want to impersonate. So we'll take the lab admin, then we specify what target service that we want to impersonate that user against. So in our case, CIFS on FS1, this is what is allowed by the current configuration. And then we provide our TGT, so of the machine account. So, and we can then import ticket directly into our session. Now, if we go back up the output of Rubeus, we can basically see two things. First, there's the S4U2Self, where our machine will request a ticket for the target users or lab admin to ourselves, so to WS1. This ticket that we get out of this request is then used as proof in S4U2Proxy. So with this ticket, Rubeus will then automatically perform the next step. So it will do the impersonation, invoke S4U2Proxy for the target we specified, so CIFS on FS1 in the name of lab admin, and it will pass along the ticket that we previously requested. So this seems to have worked as well. And now, as a result, if we look into our tickets, we see that we have really a ticket for CIFS on FS1 in the name of lab admin. So this we can then use to really access the target service. If we look at the Wireshark recording of what we just performed, we see basically those two steps. We see the S4U2Self request, where we say that we want to retrieve or receive a ticket for the lab admin for ourselves, so WS1. And this in our case works because constrained delegation or protocol transition is enabled. So the resulting ticket is for lab admin, and the flags are also good. So forwardable is set to true. That means the ticket is valid for S4U2Proxy. And we can see the ticket is BB33C, the first part of the cipher. And then if we go to the S4U2Proxy step, we see again that this ticket is now sent along in the request body of this request as the additional ticket data structure, or within the additional ticket data structure. So we request a ticket for CIFS on FS1 and send along the ticket that we just requested. As you can see, BB33C. So again, this is the same ticket that we got before with S4U2Self. And again, if the configuration is correct, everything is valid, we will get back a service ticket for CIFS on FS1 with in the name of the lab admin. And this ticket can then be used to actually access the resource. So let's quickly try that. We'll simply issue dir command on FS1 on the C$ drive, and you can see the lab admin in our case is a domain admin, so it has access to that resource. And in the corresponding SMB request, we can see that Kerberos is used as an authentication layer, and the actual ticket that we present to access the resource is issued to lab admin. Now, compared to the previous demo, it is also possible to configure constrained delegation on a user account, where the abuse mechanism looks slightly different, or so we have a look at that next. Again, let's first check the configuration. We now have a user account configured for constrained delegation with protocol transition, specifically as SVC SQL is allowed to delegate to CIFS on CA1 with protocol transition. Now, to abuse that, what we need to do is essentially get our hands on the credential material of this account. And there are various means how this could happen. Maybe you are familiar with files lying around on shares that contain plain text passwords. We just take this as an example for now. So this plain text password is now all that we need to actually perform the delegation and impersonate any given user. So here I'm just on the Windows client, no specific machine, and we're going to be using Rubeus. And first, we need to translate this password into the respective Kerberos key material representation. So we just provide the username and the password in the domain, and Rubeus will translate this for us. And the actual RC4 hash or the AES 128.256 hashes can then be used in the next step. So we now trigger S4U to self again. We specify which user we want to impersonate. So again, the lab admin user, for example, and the target service. So for our case, this would now be CIFS on CA1. Remember that we have a different configuration specified here, as shown right here. And then we simply pass along our actual username. So the service account that has the delegation rights is SVC SQL, and then the Kerberos key material. So for example, we take the RC4 hash. Now let's start Wireshark as well to monitor what's going on in the background. And we can see, again, essentially the same as before. Now we have a third step as well, because the Rubeus will first request a TGT, so an ASREC for our service account. So we can then authenticate the following steps. So this succeeds because we have provided the correct key material. Then based on that, it will issue the S4U to self request and request a ticket in the name of a lab admin to ourselves. So we are running as SVC SQL. Again, that succeeds as well because the configuration allows that, the protocol transition. And lastly, the S4U to proxy request, where Rubeus will request a service ticket for CIFS on CA1 in the name of lab admin. And also this seems to have worked. Let's quickly repeat the command with the PTT flag, so the ticket is automatically imported into our session. If we look at the result, we now see that we have indeed a ticket for CIFS on CA1 with the actual lab admin account. And again, if we try to access the resource, we can see that this works as expected. In the backend in Wireshark, we can see what happened. The request to the file share itself was authenticated via Kerberos, and the ticket that we used is the ticket issued for lab admin via the S4U to self and proxy mechanism. We have seen now how the protocol transition feature of the constrained delegation mechanism can be abused. Now let's look as well at some cases where it will actually fail. So we are back in our lab environment, and the first thing that we will look into is if we change the delegation permission from protocol transition back to Kerberos only mode for our account. And if we simply repeat the previous command that was working to get a ticket in the name of a different user, so of lab admin to CIFS on CA1, for example, and simply just repeat the command as is, we can see that it will eventually fail. So there are certain things that work, and at that point there is an error. So the first step that this Rubeus does is request a TGT. This still works fine, nothing has changed there. Then Rubeus will perform S4U to self, so it will ask for a ticket for lab admin to its own account, which is SVC SQL in our case. This seems to work as well. We get the ticket back, but then in S4U to proxy, the KDC replies with an error. If we quickly look at Wireshark, we can see the familiar requests, TGT request, the S4U to self, and then the S4U to proxy. And now the problem lies in the S4U to self. If we check the resulting ticket, we can see that it is no longer forwardable. And this is the case now because our account is not enabled for protocol transition. So we can still do S4U to self, but the resulting ticket will not be flagged as forwardable, and therefore the KDC will return an error. If we simply switch back the configuration again from Kerberos only to protocol transition, we can see that a repetition of the command now works as expected. So we clear Wireshark just to get a new trace. Run the exact same command again, and now we can see that the import of the ticket was successful. We don't get any errors because now the ticket resulting from S4U to self is indeed forwardable. As a last step, we can also check what happens if the target user that we want to impersonate is flagged as sensitive or in the protected users group. So for our target account, ffast, we are going to enable the sensitive flag. So it should no longer be possible to delegate this account. Now let's repeat the previous command and just switch out the user that we want to impersonate. So it's no longer lab admin, but fast, which is sensitive. As you can see, again, we run into the same error eventually. The reason for that is a bit different. The outcome is still the same. So if we look at the S4U to self request or the reply to our request, we will again find that the ticket that we get back, it still works. We get a ticket back for our own account in the name of fast, but the ticket again will not be forwardable. This time the reason is that the account is flagged as sensitive. So, and then subsequently, if we perform the S4U to proxy request, this will, as expected, fail again. Let's now talk quickly about the recommendations when constrained delegation is implemented in your infrastructure. As we have learned now, the constrained delegation is a more restrictive version of the unconstrained delegation mechanism. Specifically, the impact of abuse, if an attacker gets control over your accounts configured for delegation, is limited to a defined set of target systems. Now, there's one caveat to this, specifically regarding the services on that system. We'll cover that in the next session or section. For now, all you need to know is that while you specify the delegation to be allowed to certain systems and services on that systems, effectively the delegation can be performed against all services on those systems. But we'll talk about that shortly. We've also seen that protocol transition is easier to abuse than the Kerberos only mode, since there is no requirement for a user presence. So we don't have to either coerce or wait for a user to connect to our service. And therefore, if you configure constrained delegation within your environment, you should consider the following points. Ideally, Kerberos only mode is preferred over protocol transition, since as we've just talked about, it's easier to abuse. However, in certain scenarios, it might not be possible. Then the actual configuration of the delegation restrictions, so what kind of targets are allowed, should be again as restrictive as possible. And essentially you should avoid things like a low privileged system being able to delegate to a high privileged system. So if you have a web server and allow that web server to delegate to your domain controller, you might run into problems quite quickly. Then again, as per recommendations of Microsoft, systems configured for delegation are very powerful systems, and they are interesting targets for attackers. So you should protect them as strongly as your other high privileged systems in your environment, meaning applying hardening measures, network separation, and so on and so forth. Again, as we've already heard with the unconstrained delegation, it's a good idea to use the built-in protection features that come with Windows Active Directory, so the protected users group, or marking user as sensitive, especially for your high privileged accounts, so they are not eligible for delegation. Then in general, it's also a good idea to reduce the permissions of your accounts overall, so the least privilege principles. So when an attacker is able to abuse an account, they gain as little as possible from that. And then lastly, there's also monitoring measures that you could consider implementing, especially regarding your high value accounts and the systems that are configured with delegation rights. So as we just heard, there are some caveats when constrained delegation is used, specifically regarding the allowed services that are enabled on when you configure constrained delegation. And in this last section of this video, we are going to look into more details regarding that. Now, when we configure constrained delegation, we've already seen that we can specify targets that are allowed to be delegated to. Specifically, each target is a combination of a service type, so that could be CIFS for file share, HTTP, LDAP, MS SQL, and so on, and the respective account that operates this service. So we can see that in this picture here, we have a configuration that includes 3 different targets, each with a respective service type and a user or a computer associated with this service. Now, if we look at that, this might imply that the delegation is actually only possible against this specific service. So we can delegate against CIFS on CA1, but for example, not HTTP on CA1 or any other service on CA1. However, this is actually not the case. And the delegation can effectively be performed against any service operated by the target account. So if we specify as a delegation target CIFS on CA1, what actually is configured in the backend or what is allowed technically is any service operated on CA1 that can be a target of a delegation. Now, while this behavior seems a bit counterintuitive, there's actually a very easy to understand the reason for why it is as it is. If we look at a service ticket that is used to authenticate towards a service in Kerberos, we will find that the information about the service where the ticket is intended to be used is not cryptographically protected. So the encrypted part of the ticket does not contain any information related to the target service. It simply contains information about the user, the authorization data, pack checksums, and so on, but not the actual name of the service that the ticket was issued to. Here's a quick example of this. So while we still have the decryption mechanism enabled in Wireshark, you can see that the information about the actual target service is part of the unencrypted ticket. And in the encrypted part, we simply have additional information as a session key, the ticket flags, and so on and so forth. And that essentially means that as a user, we are able to manipulate this aspect of the ticket and change the information that is in here without affecting the any of the other cryptographically protected information in the ticket. So then to understand this a bit better, we can also quickly look into how the service type is actually validated. So when we configure constraint delegation, we specify a service type so that this has to play a role somewhere, and this is correct. The service type is only validated by the KDC when we perform a TGS request. So when a system configured for constraint delegation is asking for a service ticket that is usable for delegation, the KDC will actually check the list. So if a service requests a ticket for CIFS, but the delegation configuration only says LDAP, the request will fail. However, the actual service that then receives the delegation ticket, so the service that we delegate towards, does not validate the ticket again against the configured delegation rights. So if we come with a delegation ticket towards a service where only delegation towards HTTP will be allowed, but we use a CIFS ticket or LDAP ticket, the service does not recognize this or does not check this. And the actual logic behind this is because the service cannot actually differentiate whether this is a delegation ticket or an actual user ticket. So it simply just accepts all tickets that come in a valid format, meaning they are the cryptographic checksums are okay and the decryption process works as intended. Now, when we connect to a system or a service, we don't actively have to specify what kind of ticket we want to use, unless we're using tools like Rubeus and so on. But as a regular Windows user, we don't have to select what ticket to use towards which service. This is all based or decided on metadata within the ticket. And as we've seen before, this information is not cryptographically protected, so we can just change it. Once we have a ticket, we can substitute the service that this ticket is associated with, and the ticket will be perfectly valid to connect to this specific service. So that means what we essentially can do is substitute any valid service, so that means a service that actually exists on the target, The thing that we cannot change is the target system, since there are cryptographic materials tied to the recipient system. So we have to keep the target system the same. However, the account or the service type we can arbitrarily change. This works with both modes of constrained delegation, so it doesn't matter whether we use Kerberos only or protocol transition. And this is also supported in various tools, and we're going to look at an example of Rubeus next. Now within Rubeus we have multiple options to play around with this service substitution mechanism. One thing we can do is, while requesting tickets, we can directly specify that we would like to change the service within the ticket to be something else. So Rubeus will do that essentially on the fly. Or if we already have a ticket, let's say in this base64 encoded format that we've seen, or a ticket dump with Mimikatz, we can then use the TGS sub command to replace the service, the metadata within the ticket, so we can use it towards another service. As an example, we can see here on the first screenshot a Wireshark capture of a request for a service ticket. So this is a completely legitimate service ticket request, and we request specifically a ticket issued for the CIFS service on FS2. In the resulting reply, so the TGS rep, we get what we asked for. We get a ticket for CIFS on FS2, and then we perform the modification with Rubeus, and now the ticket is has been changed. So we just simply modified this part here. We switched CIFS with HTTP, and what you can see is that the cipher, so the actual encrypted part of the ticket where the session key is contained and the pack and so on, this is still exactly the same. So we did not touch anything of that, but as the information related to the service is only appearing in the first part, in the unencrypted part, this does not actually matter, and we can simply change that here. Lastly, let's look at a quick example on how this can actually be abused with Rubeus. Let's first check the delegation rights that are currently configured. On our account, the SQL service or SVC SQL account, we have delegation rights towards HTTP on CA1, and this is where we allow to delegate to. Now first, let's try to use Rubeus to request a delegation ticket for a different service. So we on purpose are going to specify a service that is not allowed by the current delegation configuration, namely CIFS on CA1. Remember, we are only allowed to delegate towards HTTP. And then along with that, we simply have to specify our credentials again. So this is essentially the same as we done in the previous steps. If we issue this command, we will see that it will eventually fail. So what Rubeus does, it first it requests a TGT for our service account, so this works. It then will perform S for U to self. This step still works as well because there's no mention here yet of the target service. We just ask for a service ticket in the name of lab admin to ourselves, so this is successful. But then if we try to request a delegation ticket for CIFS on CA1, this actually will fail. And again, if we look at the Wireshark capture, we can see the same thing. We request a ticket for CIFS on CA1, and as a result, we get this bad option error. And if we check the Microsoft specifications, we can quickly see that this aligns with the expectations. So in case we ask for this ticket, so S for U to proxy, and the service name or is not in this list of allowed targets where we are allowed to delegate to, the KDC will return this bad option error. So this is behaving as expected. Now let's repeat this command and actually specify this time a service where we are allowed to delegate to. So we do the exact same thing as before. We impersonate again the lab admin user, and this time now we specify the HTTP CA1 service. Again, if we verify that, that's where we actually would be allowed to perform delegation to and provide our credentials again. So the same thing as we've done before. This should now work because everything is in order. And this is indeed the case. So now we can step through all the 3 steps. We get the TGT, S for U to self, which results in a valid ticket to ourselves, and then S for U to proxy, which results in a valid ticket in the name of lab admin towards the service that we actually want to accept. We requested, so HTTP on CA1. We can also see in Wireshark, no errors there, everything looks as expected. We have all the different requests, and then eventually in the S4U to proxy, we can see that we provide the additional ticket in the name of lab admin and get back a valid ticket, which is issued for HTTP on CA1 in the name of lab admin as well. So this all looks good. The problem is now with this ticket, we are still not able to actually access a different service. So if we try to list, for example, the C drive on CA1, this will fail since our Windows system now currently does not have a valid ticket for CIFS. We only have a ticket for HTTP. And now at this point, we can actually make use of this service substitution mechanism that Rubeus offers. So there are essentially 2 methods. We can repeat the same command again, where we get a ticket that is valid for HTTP, and then we can use the TGS sub command of Rubeus to, within this ticket, replace the service type. So we specify the TGS sub along with the alt service flag, and now we say we want this to be changed to CIFS. We provide the ticket where the modification should take place, and then Rubeus will do that. You can see that there's no additional request in the background since Rubeus just modifies the ticket locally. So the resulting ticket now is issued towards CIFS, and we have instructed Rubeus to directly import it, and now we can see that we have effectively 2 tickets in our session now. One is HTTP, one is CIFS. If we look at the data itself, we can see that this is really a copy of the ticket. So the expiration time, start times are completely identical. So since we just changed this metadata. And now if you try to access the share, this now works because Windows now has a valid ticket to access the share if it looks at the metadata. And if we look at the session setup request in SMB, we can see that the ticket that we are using is indeed the lab admin ticket for HTTP, or not for HTTP, for CIFS in our case. So that seems to have worked. Now the other thing that we can do is instead of getting a ticket and then replacing the service, we can instruct Rubeus to do that in one step. So we again repeat the previous command where we impersonate lab admin, we specify a valid service, so HTTP on CA1, we specify our account credentials, and then lastly, directly in this command, we can also provide the alt service flag and say, hey, please change this to CIFS directly while requesting the ticket. So again, let's trace the steps that Rubeus has performed. First, we get the TGT, nothing new. We perform S for U to self. Again, there's no mention of the service in here, so this is as before. But then in the S for U to proxy step, we can see that first Rubeus will request a ticket for HTTP, but then it will change the ticket for CIFS as instructed. So the S for U to proxy request will happen with HTTP and CA1, but the actual ticket will then be changed on the fly to include the CIFS service type. So again, we have that now imported in our session, and now we can see that these are not the same tickets anymore. They have different expiration times since we have requested a new ticket and changed the information within the ticket itself. This concludes part 5 of our Kerberos deep dive series. Feel free to leave a comment in case you have any questions or remarks. Thanks for watching.